Sir,
Hello.
hello.
Yes,
Sir, previous week PPT, sir.
I have already shared it in the drive.
Sir, this all PPTs of 4 weeks will be the same only, same thing which you uploaded.
Yeah, it will be week 1, week 2, week 3. I have created different folders.
No, sir, that YouTube is there week 1, week 2. What about the PPT folder? So there is only one folder, no, sir. It contains all the 4 weeks.
Yeah, there is all the weeks, right? Week 1, week 2, and everything.
But in the folder PPT, there is only one folder, sir. One link only is there. Not week wise, only one was. But for YouTube, all 4 are there, 3 are there.
I think you should check the second option, like the one given below. There are 2, right, in the Excel file. So
Actually, sir, in the Excel file to the left, there are YouTube links are there, which we are going through, and to the right there is only one link which gives the PPT.
that is not mine.
Okay.
Actually, the whatever I have shared is right there in the below. There is a folder, drive folder. So if you can open, so let me just share it.
Okay. So in the folder.
1 minute, 1 minute. Just wait.
So every week you'll be uploading one folder, no? So every full week.
1 minute. Just wait. I'll just show you that. So here, if you
Yes,
see,
sir. Yes, sir.
So here, if you go,
okay,
week 1, week 2, week 3.
Okay.
So week 1 we had, week 1 we only had slide. And week 2 and week 3, week 2 we had notebooks.
Okay.
Then
And
week
week 3 now it is week 3.
Yeah, now we will discuss that.
You'll be uploading last week for also, no, sir?
Yeah, I will.
Okay, totally okay. Thank
The
you.
drive link, sir.
Drive link is already in this Excel file that is shared with you from NPTEL.
From email, sir.
I think they might have shared it in email.
And the previous courses or the instruction itself is to upload, sir. That is the thing. But I don't know some difficulties, sir.
From QR code, sir.
Let me just share this 1 minute. So can you see the link? So here, if you see,
yes.
So this is the link. You can just take a photo or something.
Okay.
All right.
Can you show the link, sir, again? I'll take the photo.
1 minute.
Okay. This is the link, no, sir?
Yeah, this is the link.
Okay, thank you, sir.
All right, so we'll start the class now.
Yes, sir.
Mhm. So last week, we were discussing about different sequence data types. So we had um, discussed different operations. So pandas can be actually considered as the mm, Excel or Excel kind of thing that can be used in Python. Right. So we have two types of series or types in pandas. One is a series, which is a 1D labeled array. It's a one data type and it's a single, like we can consider it as a single spreadsheet column. And we have the data frame, which is a 2D table of series, which is having indices also, like the whole spreadsheet that we use in Excel. So a data frame is a dictionary of series, is a dictionary of series that shares an index. So if you remember the NumPy, so NumPy will be just a or if you initiate an array, NumPy array, it is just defined by the row indices or column indices. Whereas in a data frame, each uh, row or column is associated with an index. All right, so here we'll start with some examples. So we have the data that is also uploaded in the drive. You can access that. All right, so this block is just to load the data. So here we are loading the data. All right, so nothing much. This is just the standard way of loading the data to our notebook. Now let's see the building blocks of a series. So a pandas series is a NumPy array plus an index. So a NumPy array having an index can be considered as a pandas framework or pandas series. So index is what makes it more than an array. So you can look values up by label, and the pandas will align two series by label when you combine them. So one important thing or one advantage of using pandas framework is like so just like we filter in spreadsheet, we can filter the values by using the names of the columns or rows. So so if we create the series, so let's say this is our data and we are creating the series pd.series. And if we print the series, we can see that it is already associated with the indices. Okay, so here we have the data type, which is integer 64 here because every element is an integer. Then this is just or the array which is used to create the data frame. Then we have the indices. So these are the indices that we have right now. So s dot index, because s is a pandas series, the s dot index will give the names of the indices. Now let's create some meaningful indices, right? So that's why we need indices. If it is just 0, 1, 2, it's kind of similar to what NumPy does or anything else does in part. In like in the any sequence data set, we have seen that we can access the elements using the indices. So how pandas become different is like we can give meaningful names to the indices so that it is easily recognizable or easily accessible. And here we are giving a name to the series also. So if we print these series, so here we have the values of the series, then here is the indices. So this is the temperatures series, and on different days, what are the temperatures? So if we print it, so here we have the indices and the values. So that is the advantage of using Pandas series or any Pandas web. So here, if you see like how to access the temperature at Wednesday, instead of just giving slicing indices, we can just look up by label. So here we are using the label Wednesday to get the temperature corresponding to that day. Similarly, if we don't want to use it, still it will have the these indices will always be associated with it, but it is kind of hidden. All right, because you can always look up their temperature using the location, using this syntax, that is I location, and in that is in this location, and we have to give the locate in this to locate the temperature at that index. Here the Monday will be 0, Tuesday will be 1, and Wednesday will be 2, and so on. All right, so now let's see another way of initializing the series. So earlier we had used like two arrays. So here is one array and here is another array. Now a kind of like a dictionary. So this is a dictionary that you can see here. So from directly from dictionary, we can initialize the series, and when doing so, the key of the dictionary becomes the index. So keys become the index, and whatever the value is associated with the key will become the value of the Pandas data frame, Pandas series or Pandas data frame. And let's see. So here we have we are printing the Pandas series, and we can use different functions which are inbuilt, like which is having the maximum population, and all those things can be printed here using the max or ID max. ID x max will give the index of the maximum population. We can also filter it, right? So just like using conditioning, we can filter the series using the conditioning statements. Now, what is automatic alignment? So it's a feature that separates a series from an array. So when we combine two series, so Pandas automatically lines them up by index level. It's not by position. Okay. So here, let's say the labels are present in one, but not the other. If we are combining two series, and if one of the label is absent, then automatically a nan or nan value will be assigned to that. Okay, let's see how it is done. So here we have two series. So one is A, which is 1, 2, 3, and label is X, Y, and Z. And the next series is B, which has the indices Z, Y, and W. So it's a different order and different labels. So we are converting A and B to string and printing the same. So we have A, then B. Now we are trying to print A plus B. Okay. So what is A plus B? What is it giving? Okay. So let's say W had a NaN value because W was not present in A. So it gave a NaN value, and X was not present in B, and it again gave the NaN value. But other indices like Y, it automatically adds with Y, and Z also adds with Z. So there is no confusion in that. So what we have to note is that Y matched with Y and Z matched with Z, despite being having different order. If it was a normal NumPy series, then what would have happened is this would be 0, 1, 2, and 0, 1, 2. And if we add, the result would have been 11, 22, and 33. But here it is not happening. And it is to be noted that W and X appear only in one series, so they become 9. All right. So now let's build a data frame. So what we have seen right now is series. So which is kind
Series.
of, yeah, series is kind of like a 1D data frame. Now we are moving to 2D data frame. So let's build that. So here we have three column names, let's say, and these are the values which will go into those columns. All right. Um, just a minute. All right. Sorry for the interruption. So now we are going to build the data frame. Right. All right. So let's see how it looks like. So here we are building three columns like name, age, and city. So now if you print the data frame, it looks something very similar to what we see in Excel, right? So here we have the column names and the row numbers. So that is how it is. So let's say if we print the shape, you can see that the shape is 3 cross 3. The indices are not included in the shape. So the data 3 cross 3 does not include the indices. So the columns we can again see by the columns, and indices we can see by the syntax. Now we have another uh, data frame. So it's from a list. We are trying to create it. So here we have a pair of data. So all these data are related. So max 95 and A is related, and science 88 and B are related. So we will give these into the pd.data frame syntax, and we define the column names. All right. So finally we get the data frame as printed below. Now, how to do that again from the NumPy array? So you might be thinking like we are naming the columns, why not the rows? So we can do that as well. So here we are creating the array. So it's just a random array, or it's not a random array. It's we are arranging 12 into the shape of 4 into 3. So 4 rows and 3 columns. So now we are giving the columns names and also the row names, or row instead of indices, not random indices, the indices that is automatically assigned like 0 to 0, 1, 2, 3. We are giving the index naming. So if you print that, we get something like this. So here we have the data from 0 to 11. Okay. And if you want to convert a pandas data frame back to the NumPy array, we just need to use this syntax to NumPy, and we have to use the brackets. So what is actually a data frame? So data frame is really a dictionary of series, right? So let's try to uh, uh, see what each columns define. So let's pull one column. So we have the students. So I don't remember where we have created that. So let's see. If it will work. Okay, so this is it. All right. So this is the actual data frame that we have. So we have the name, age, and city. So Jack, Riti, and Atiti. Now we are just pulling out one column using the column name, and we are trying to see the type of that pulled out column. So what it gives is it's a series. So it's so each column is a series, Pandas series. Now if we print the column, we can see that 34, 30, and 16 that are the ages, and along with an index. So what each column is a series or is a Pandas series, and a collection of or a dictionary of Pandas series is makes a Pandas data frame. All right. Now how to read a file? So in many cases, um, many data will be stored as CSV files. So for example, so this is a CSV file. So what CSV file have is like it can have different mm, headings which are separated by commas, or any delimiters will be there. Can be space also, or commas, or anything. So here we have the data associated with that. So each of these commas, so let's say, so this is one column of Sendosa which belongs to this species. So how to read such files, right? So when we cannot always create data frames like what we have seen already, like creating or typing everything into list or anything. We already have so many data that is stored in CSV files. So let's see how we can read the CSV file. So the syntax used for that is pd.readcsv. So that is the function that we will see mostly in our sorry your career. So if you are using Pandas, it's just to manipulate or do engineering over the data that we have. So let's see that. So these are the parameters that goes inside this bracket. So separator. So what kind of separator is used? So default it is comma. So in most of the CSV files, the default one is so comma. Then index column. So which column becomes the index? Then which all columns we should read. Then we have the parse dates. So converts. So sometimes the dates may be in different formats, so which can be converted into real dates. Then NA values. So sometimes when humans enter data into CSV files, there can be missing values in the CSV file, or some readings may not be available, may not be accurate. So those values will not be entered into the CSV file. So how to manage those files? So here we have the NA values. So NA values is string used to manage that. Then and rows. So if we give a values to n rows, it will read only the rows up to that number. So if our CSV file is too large to load, we can just load a limited number of rows. So here first we are trying to. So this is our CSV file that we are trying to load. So here we have the date, then customer type, then quantity, price, and revenue. All right. So I think here one value is missing. All those things we'll see how those are managed. So first we load the data. So we are just loading the data. Sales is equal to pd.readcsv. Then the path to the data that we are giving. All right. Then we have print sales.head. So what print sales.head will do is it will print the first 5 rows of the data pandas data frame. So if we see the first 5 rows, we can see that if you look at this CSV file and the if you look at this CSV file, and if you look at this pandas data frame that we have loaded, it looks much clean compared to the CSV file. So here we have the date, then product, region, customer type, quantity, and in the price, we have some NaN values and revenue. All right. So if you look at the date column, let's see the type of it. So it will come as an object. Okay, object or object means object data types are those. So if you look at here, so this is an object, this is an object, this is an object, and these are numerical or float, all those things. So date is coming as an object data type. So it came as a text, came as a text and not as a date. So this read CSV, it will not guess the type of data um, based on what it is, but it will. But we have to be specific on what data it is exactly. So let's see how to do that. So first we have seen
Sir,
the
we have to specify the folders files, sir.
yeah, we have to give the path to the file. We have to give.
Complete which drive is there, everything.
It's not exactly like so if you're starting, so now my IPNB file is here
Okay, okay.
and my data is here. So let's say, so it's kind of confusing, right? So we just need to give this data and CSV. So this will load the file.
Okay.
All right. So it's like from wherever you start, you have to give the sale. You have to give the path. So if the sales was rightly in here in the same folder, then you can just use whatever the name of the file.
Directly you can give files name also, no?
But if you give now, so let's see. So it gave an error, right? Because the file is not found. No such file or directory. So we have to give the correct path from where the file is present. So now
Okay,
the file is here. So we have to give that. All right. So
can
so
we
we
access it from drive, C drive or D drive?
yeah, everything is fine. Then you have to specify from wherever. So if it is from C drive, you have to give C, then whatever the folder name as such.
Okay.
But usually that is not a practice. Like if your data is very huge and it is stored somewhere else, usually what we do is we will mount the data into our working directory and do the whatever we want to do. So it's easy to access the data. So here we have to use this parse date. So since the date is identified as object, we have to be specific which column is the date. All right. So let's see now the data types. So now the data type date has date time 64 format. All right. Okay. So now let's so once we have done everything, all the um, things that we need to do. Now, how to save the pandas data frame back to a CSV file. So this is how we can do it. So let's say, so this demo is a copy of the student. Then let's print her demo to CSV. So let's see. So we have the we don't see the pandas data frame anywhere. We just see the CSV format. So to CSV is what it um, do the pandas to CSV conversion. All right. So this is a standard practice of followed whenever we load or whenever we use the pandas data frame. So first, we'll see if the data has loaded properly. So that for that we'll use the dot head command. So that first few lines of the data is loaded correctly. Then the shape. So the shape gives how much data is present. So here we have 202 rows and 7 columns. The info gives the overall picture of the data the data that are present. So here we have different column names. Then how many values are present, like how many non-null values are present. So here in the region we have some null values, and in the price also we have some null values. We also get the type of the data which is store, which is which the each of the columns uses. So what does this tells you, right? So we have 202 total rows, but the region has 196 non-null and the price has 195 non-null rows. So there are gaps in the columns. So and also different data types we have presented. Now if we use this dot describe, so it will give the different um, numerical values, statistics like minimum, then different quartile values and maximum and standard deviation. Also the mean value is also calculated. So describe is like the command where we cache impossible data, like check the minimum, maximum. So all those can be printed in a single command. So we need not check each column to get minimum or maximum of that column. Just using this command, we will get all the required details. Then we can. So we have already seen that our data has different kind of data types, like we have object data type or numerical. So usually these object data types are considered as categorical columns because they are categories, right? So let's say, so let's go back to our data. So these are kind of categories like east, west, south, and north. So that is only 4 values will be present in this region column. And then in product, maybe 10 or how many products, unique values, we don't know. So here we have headphones, phones, and tablet, laptop. So it's all limited. And here are the customer types also maybe only two types of customers, new and returning. Whereas the quantity, price, or revenue, they can take any values. There is no limit of the values it can take. So that's why we have two kind of data types, that is categorical. Categorical usually have these object data types. So here we have customer type, region, product. So if we tell to describe and include only the object, then we can get, say, so here if you have seen this describe, it automatically takes the numerical. So here if you see include is data types all, and we are not passing anything, so it will automatically take the numerical values. Whereas if we explicitly say we have to include the object data types, then we are going to get the description of the object columns of the data. So here we have the product, and we have 4 unique kind of products. So I think it was headphones, phones, laptops, and tablet. Then region we know northeast, southwest, and customer type is new and returning. Okay. So here the top quantity, like the phone is having the highest frequency of 58, then east is having the highest frequency, and returning customers are in the highest numbers. So this is so this is a description for each of the object data type. Then if you want to get the count of each of the categorical data type, categorical values in a column. We can select the column and we can use this value counts. So if you use that, we can get the values of the different products or how many times it is repeating. Okay, then this is just the proportion or the percentage of the percentage in that column. So here we have value counts and normal is equal to true. We have passed. All right. So, so some of the other structural attributes are, so we can get the columns using dot columns and indices using dot indices, dot index, then size of the total size of the data. It gives, I think it was 207 into 202 into 7. So that is 1414. Then minimum dimensions. So not minimum dimensions, number of dimensions. So here the number of dimensions was 202 into 7. So that's only 2 dimensions. All right. So let's see how we can sort the values in a Pandas data frame. So we have to just select the column that we want to sort, and we can select if we need ascending order or descending order. So if we need descending order, we have to pass ascending is equal to false statement. Then we can get the, and if you just, this is just to get the first 4 rows. So if you look at here, the indices are also sorted accordingly. Again, if you want to sort multiple columns, so here what it will do is the first the region will be sorted in ascending order. So E comes first. So the region is first sorted. Then inside the region, the sorting is done for the revenue. All right. So here, if you see the revenue is getting decreased in the East region. Now we can also filter the things. So if you want the largest 3 values of the revenue, and we just need only these 3 columns, or the values correspond to these 3 columns, we can use this syntax. So this is some things that you can practice. So the notebooks are already available in the drive, so you can make use of that. Right. So series, so the summary of this notebook is series is a 1D labeled array, and data frame is a dictionary of series, sharing an index. Then combining series aligns them by label, and so that's what we have seen, not by position. So we have seen that using the example XYZ and YZW. So if there is any unmatched labels, we will get a then value. Then if in a data frame, we can access the columns by indi using this syntax. All right, then read CSVs. We saw how to read the CSVs. Then to CSVs to convert our data frame to CSV. Then this is the standard practice when we load a pandas data frame from the using a CSV file. All right. So now we move to the second notebook. So second notebook is more of like so since we have familiarized with the pandas data frame syntaxes, now we'll see how we can make use of some different functions. So this is where real analysis is, like get the rows that you want or get the columns that you want, then fix what is broken, like the NaN values and everything. All right. So this is for one column, which will give a series, then several columns will give a data frame. Then we can get the rows by label or rows by position, that is I index location. Then we can use conditions to filter, and this is to get one of the sets. So again, we are just using the same um, data loading procedure. So here we have the sales data that we have loaded again, right? So now let's try to select one of the columns. So one of the columns can be selected as the label of the column, that is the product. Then we also have so if we want to get a subset of the data frame, that is different columns, then we can use this syntax, that is two brackets. So this one will give a series, and this is going to give a data frame itself. Now we have, so that is it. So it's always preferable to use the bracket format rather than the um, dot notation. So dot notation is like a sales dot region dot head. So it's like it's kind of good. It's kind of okay. So it's take the sales dot region is the name of the column, but the problems comes when there is a space in the column name or everything. It's always preferred to use the bracket format. So whenever there is a space or punctuation, it fails. It will give use a syntax error like if this is the case, or if there are kind of some of the terms are already reserved for the um, data frame method, like df.count, df.max, or df.shape. So if any of the column names coincides with these names, then also it can cause an error. Okay. So the brackets always work. So now what is location and iLocation? So we have seen it briefly. So location works on labels, and iLocation or iLocation is index location works on positions. So it's just like any other sequence data type that we have seen in the last class. Okay. So one thing to one thing to be taken care of when using location and iLocation is, so even though these two looks almost similar, so 0 to 3 and 0 to 3, but when we see location, so location takes the indices, like the actual index names. So it will take from starting to stop, like the stop is also included. Whereas whenever you use iLocation, it's similar to what we have seen in the previous um, slicing of the sequence data types. So it will include 0, then it will exclude the last index, that is 3. So now we are trying to um, set a new index for our data frame, or we are trying to create a new data frame, let's say, so that the data frame name is by date. Then we are just using the old data frame and setting the index, or that we are using the date column as the index. Okay, so let's see.
I mean,
So
അതായത് മാത്രം മതിയോ തവളക്കുഴി?
So right now the date column acts as the index. So now if you want to locate any column, any row, we can use the date and get that row or row. Now, so let's see how to get both um, rows and columns together. So here we can, so here we are trying to print the 0 to 4th row, and we only want the products and revenue column. This is the syntax used for that. So inside the allocation, the first part denotes the rows, the second part denotes the column names. If you are using the I location, then again we have to be specific of the from start and stop, and the 5 is not included. And here we have to give the number of the columns. But the problem is like, so if you read this, it's like easy to understand, like we are printing the 0 to 4 rows and the columns are product and revenue. But if you look at this, like if you look at that after a short period of time or long period of time, it's much harder to read it. So it's always preferred to use the dot location format. Now, how to get a single cell, right? So if it was a sequence, a 2D sequence or anything, we could just use the indices and got the um, value at that location. So similar to that, we can just give the row number and the column name, or the row index and the column index name to get that value. And I location also, I at also works the same. Boolean. Now let's do some um, Boolean filtering. So what is Boolean filtering? So Boolean filtering is kind of like adding. So here we are trying to create a new series. So if we pass this sales revenue and give a condition, so it is going to make a new series of true and falses. So this is what the new series looks like. Whenever the revenue is greater than 5,000, the series will have the value true, and whenever it is less than 5,000, it will be false. So here we have created a mask. Then the type of this mask is Boolean. So if you want to see how many of them are true or how many of them are greater than 5,000, we can just use the sum. And if you do the sum, what happens is it is going to sum the, so true is actually equal to 1. So if you do the sum, it will sum all the ones and zeros, and all the ones will be added. Right. Now how to filter that, right? So now we have the so now we have this series of true and falses. If we just pass that series into our actual file, then all these columns will be filtered based on that. So wherever the true happens, those rows will be retained, and all the false will be discarded. So if you see this product revenue, you can see that all the revenues are greater than 5,000, and zeroth row is not there. 2 and 3 are missing. Similarly, 5 to 7 is also missing. So there is filtered data that we get based on this series. So now if you see the number of rows and columns of the new series, it's just 48, because we had only 48 trues in this series. All right. So this is another way, like So if you don't want to create all this mask and everything, so what we can also do is first give the condition. So it's kind of sales, then we are getting all the revenues greater than 8,000, and we select what columns need to be printed. So we have those columns or those columns and filtered rows. Now we can combine multiple conditions, right? So we can use the and or not. We cannot use these Python keywords like and or not as in a word, and we have to use the bracket for every condition. Okay. So let's see how it is done. What's the correct format? So we are trying to select all the products that is equal to laptop, and the sales revenue has to be greater than 5,000. So after filtering using these two conditions, we can see the total number of rows is 26. So let's see if we don't have, if we are doing without these brackets, what it is going to do. So if there is a missing bracket, then we will have the type error that we cannot perform random with data type float, array, and a scalar of type. So whatever it is, like it's a value error that we will get. Right. Now moving on. So let's see how to see some values are in a column. So for that, we can use the isin command. So let's see. So here what we are trying to do is, so we are trying to take the product column and we are trying to filter out the phones and laptops. So if you print the link, so you can see then there are 108 of that. Now we can also see, you can just use this not symbol. What it do is it will filter out, or it will not print headphone, or it will filter all the things other than headphone. So headphones will not be available in our final data, or other categorical things will be present. Similarly, we can use the between. So if we have some numerical things and if you want to get the value between these two, so what one way is like it has to be greater than 1,000 and greater than and less than 3,000. That is one way of getting the same thing. Another way is using the between function. Okay, so let's move on. So these are just the updates that we can see in the Python Pandas 3.0. All right, so it's just a standard thing now, so there is nothing to worry about. All right. So now let's see the adding, changing, and removing columns. So we are just making a new data frame. So we are taking the first 10 rows of the sales CSV, and we are copying that to our data frame. So now we want to create a new column. So that is discount, and the value is given us 0.10. Okay, so if we give that, all the rows are going to get the same value. And we are adding one more column, which is net. The net value is nothing but df.revenue into 1 minus discount, whatever it is. And this bracket is used only to round it off to 2 digits. So here we have the final df. So here we have two new columns, that is discount and net value column. So what does dot var do? So what it is doing, what it will do is, so here we are trying to add one more column, size. Then what we are trying to do is, so in the earlier case, what we have seen is like if we add the column and if we give some values, it will be copied to all the rows. Now here it is a conditional addition of the column. So if the value of the revenue is greater than 3,000, in the new column will give the value large. If it is less than or equal to 3,000, then the value will be small. So here we have the new column size. So where the revenue is less than 3,000, it will be small. If it is higher, then it will be large. Okay. Now let's say we have more than two outcomes. So here we have just two things can be done. That is either it is greater than 3,000 or less than 3,000. Whereas in here, if you do the df.revenue is greater than 5,000, or another condition is df revenue is greater than 2,000. So if it is greater than 5,000, it will be considered as high. And if it is greater than 2,000, it will be considered as low. If none of this is true, then the default value of low will be given to the will be stored in the column. So that is what we can see in this band column. All right. So this dot apply is also kind of a way of initially giving these conditional things. So in that case, we'll have to use the syntax and give the function. So if x is greater than 3,000, then we'll give large, else we'll give the small. It's identical, but it's kind of slow, I guess, computationally. All right. So it's just to see the time. Mhm. So it's, apply method is taking more time. Okay. So let's say if we in the final data frame we don't want a set of columns, then we can use the drop command. So in the drop command, if we pass the name of the column, uh, these columns will be dropped from the data frame. So if you look at the final list of the columns, so after drop, the so let's where is it? Where is it? Yeah. So after drop, we cannot see these columns in our name of the in the column names. You can also rename the columns. So customer type is renamed as customer. The size is renamed as order size. So let's see is it done. So yeah, customer type is renamed as customer, and size is renamed as order size. So here we have the dot rename syntax used to rename the column names. All right. Now how to handle the missing data. So first let's check how many data are missing. So for that we can just use this command sales dot list, and name means is nan values, then dot sum. So it will give the nan values per column. So here we have 7 nan values in the price and 2 nan values in the quantity. Okay, so total missing is 15 or 6 here also in the region. Total we have 16, and we have 50 rows with gap, right? So there is some values missing in 15 rows. So here is 50% of missing data, and all those things can be done using the command. Now, how to handle these data, right? So either we can drop those columns, or there can be some methods that we can fill those data, which will not be the actual data, but some estimate data. So let's see. So these are some of the rows where we have the NaN values in the price column. So recovered. So if we have the revenue column, we can know the price, because revenue divided by quantity will give the price. So we can just use our domain knowledge to fill the column. So let's say the filled one is the new sales dot copy. Okay, so here we have the recovered prices. So these are the recovered values which we have, which were NaN before. So what are other options that we can use when we have NaN values? So let's say we have another small data type. So here we have the NaN values in three rows, and which is in column A and column B. So one thing that we can do is drop NA. So that will drop all the columns, all the rows which have the NaN values. So after dropping, we'll have only 0 and fourth row where there is no NaN values. Okay. Or if our data is more valuable in the A, so if the NaN value in the B column does not matter, and the values in A matters, or in the calculation or anything, then we can draw up only the NaN values in the or the rows where NaN values are in the A column. So that is another way. So here if we draw, we use drop and then pass the subset equal to A, then only this second or the third row is only dropped. And then another way is to fill the NaN values. So here we are filling the NaN values with 0. Okay, so that is one way. So if we can fill the NaN values with 0, or fill the NaN values with mean of the column. So that are another way to handle the NaN values. So if you fill the values with 0, all these NaN values will be converted into zeros. Whereas if you fill with the mean, so what is the mean? So it's 10, 30, and 50. So what will be the mean? 10 plus 30 is 40, plus 50 is 90. 90 by 3 will be 30. So these two will be filled with 30. And here 1, 2, 8, 12. So this will be converted into 3. So let's see that. So here the second row is 3, and these two NaN values are converted into 30. Another one is F fill and B fill. So here it is the carry the previous or next value forward. So it's kind of like a, so let's say we have the data time series data. So by our knowledge, we know that the values will not change much from. So let's say we have the temperature of today is 30, then tomorrow it may not change much, right? It cannot drastically go from 30 to 20 or something. It's possible, but the chances are less. So we'll try to fill the values from the adjacent cells. So that is what F fill or B fill will do. So F fill will use the values before, so last non-value, that is this values will be carried forward. B fill will be from using the backward step, like from 30 it will be from the row below, it will take the value up. So both are used. We have to use some of our domain knowledge to whenever we do this data filtering or data preprocessing. And sometimes when humans do the data filling, in CSV files, there can be duplicate rows. So it's better to remove those, right? So there's no point in keeping two rows of identical values. So we can see that if there is any duplicated rows, so sales.duplicated will give the duplicated rows, and if you sum it, we can get which all row, how many duplicated rows are there. So here if you see, we have two duplicated rows. So which are the duplicated rows? So here is one duplicated row and second duplicated row. So we have two duplicated rows. So if we just use drop duplicates, we can drop the duplicate rows. So before we had 202 and 8. So after dropping those, one of the duplicated rows is kept and others are removed. So it may not be two. It can be much higher number also. Okay. So here are some of the practice for this notebook, which I will leave to you to do at home. And the summary is just what we just discussed. So I will move to the next notebook. So yeah. So these are some of the advanced topics that we find or we practice. So again, we are loading the data here. So let's say we load the data and everything is done as per before. So what we want to do is we want to split our data based on some group. So what we're trying to do is sales group by, and we give the column name so that the new data, new G will have how many unique values are there in this product. So that much number of groups will be there. Okay. So if you see the number of groups in G, we have 4 groups. I think it's 4 products that we had. So group sizes are G.size. If we do it, we get the group sizes. So headphone, laptop, phone, and tablet. So those are the 4 different groups that we have, which is got by this group by function. So now what we are trying to do is, so we are trying to group. So we are trying to group by products, and we are adding all the revenue in one group. So the total revenue of each of the products will be available in this total data frame. Okay, so here we can see that the total of the laptop, phone, tablet, and headphones are here. So why group by is advantageous, right? So if it was so what we had to do if it otherwise what was the native approach, or the if we have not used group by, we'll have to use the conditions like if the product is equal to laptop, then we have to select the column, filter it, and sum. So instead of that, the group by will give the values in just one line of code. Okay. So here again, so what we have seen here is like we are just so if we don't use this, we don't see any indices as such, right? So if you want to group the products, so here what it actually does is our products become the indices, and these are the values. That's why if you look at the type of this data, we have the type is a series. So we know the series will have just index and the values. But if you don't want to use our whatever the column that we are grouping by not to be used as the indices, we have to pass this explicitly as index is equal to false, so that our whatever the column that we are giving will not be used as the index. All right. So now if you check the type, it will be a data frame. Okay. Now again, it's not just a sum that we can do. So we can do different metrics around if using the group by it can be the sum, mean, and how many counts and the maximum value. All those can be done using a single line of command. So if you want a more clearer version, then we can also use we can um, name the columns, right? So we can total is the sum, then average is the mean, then orders is the count. These are the mm, Python specific or data frame Pandas specific words which cannot be used or which can be used, but these are the reserved keywords for different function. But if you want to have more meaningful or more readability, then we can define the column name. All right. So this is again the same thing. So here what we are doing is um, we are grouped by the product, then revenue. In the revenue total, we are calculating the sum of the revenue, whereas the quantity total, we are calculating the sum of the quantity. So it's not always like so. If you see here, we had given the revenue column, so all these calculations were based on the numbers in the revenue column. Whereas if we want different columns uh, to be present in our final mm, data frame, so we can give a column name and whatever operation that we want to give. Okay. So n unique is a function or keyword that is used to see how many unique values are there in that column. Now, here is another way of grouping things, like we can group by two different columns. So what we are doing here is we are grouping by product and the region. So first, each of the product, and inside the product we'll take care of the region and whatever operation that we have already said above will be carried out here. So what is transform was aggregate to? So these are also another functions in Pandas. So aggregate returns one row per group. That is, the table will usually shrink kind of. Then a transform will return one row per original row. So let's see what it actually does, right? So let's say we are copying our sales to the data frame. Then we are adding new column product average. So we are grouping by product and revenue and transform mean. Okay. Then we have the average also another column. This is the product average. This is another column that you are adding. So what we are doing here is we are uh, doing subtraction of our product average, which you just added from the revenue. So these are the two operations that we have done. So let's see. So what aggregate mean would have given is like So aggregate mean would give only 4 rows. The transport mean gives how many rows are there? All those rows will be given. So let's go back. So here, if you see the mean, whatever we have done, finally we are going to get only 4 rows, right? 1, 2, 3, 4. How many different groups it has? So that is what aggregate do. Whereas transform will do, or it will do it for each of the rows. Now, finally, pivot tables. So pivot table is used to, when we can group by with 2 keys. It's not a stacked index, but so let's see it's how it is. So again, we use the same data, then use the pivot table. Then values are revenue, and we are using the index as product. Okay, then we are using the columns as regions, and aggregate function is a sum. So if there is any non-values, we'll fill it up with zeros. So let's see what it is doing. So pivot table does it gives the east as so we have given the region column, and we have given the product and revenue. So here we have the product and revenue for each of the so let's say what it is. So in the east region, headphones sale is this much, and so it's kind of creating a matrix kind of thing. So this is kind of same, right? So if you look at here, so if you group the product by region, first we group by product, and inside the product we group by region. So we'll get the revenue of each of the product in each of the region as data frame, and the same numbers are replicated here as well using the pivot table. Right. Since we are rounding off to 0, maybe, yeah, we are rounding off to 0. We are getting all zeros here. We can also add total for each row and column. So for that, we have to just pass these two comments. Now, this is another. So this does not actually give the values or the sum. It just give the count of the values. So here the headphones with new customers is 20 numbers and returning customers 29. So if you add all this, we should end up with 20. All right. So this is just the percentages of this same table. Now how to join two tables with a merge function. So first, let's see. So here we are using a new data set. So let's say, so this is a new data set, very small. So we have region, manager, and target, and 4 rows: north, south, east, west, and names, and the target value. So this is our data frame that we have. Now our old data set had 200 rows, and 6 of them have no regions, right? So there was NaN values. So after removing the duplicates, we had 200 rows. So now let's see how to merge. So we are trying to merge the sales dot merge, and we are passing the regions data frame, and where should we merge? So that is on the region column, and then let's see what this does, right? How is equal to inner and how is equal to left. So after merging, so here is the sales. After merging, the inner lost the rows with missing regions. So that we have seen before also. Like if some label is not present, it is going to be missed. Then left is like kept every sale and manager is nan where region was. So that is it did not kept every columns. That is the shape did not change, but two new columns has been added. So it's kind of like so our region had so what it actually did is like, so in our sales data frame we had the region east, west, south and north. Then when we merged it with the regions where it is small data frame, so wherever the north is there, we will see these two columns values, new two columns, manager and target, and we can see Asha and 1,80,000. So wherever there was north, so north we can see the corresponding manager and the target. So the inner join, what it does is it quietly dropped 6 rows and where the region was missing. So it can lead to wrong values. So it's always good to check the shape before and after merging. Okay. So again, we have another way, that is outer. So this indicator is equal to true is a tool that will tell us. So let's see. Okay. So here the region is missing, and so here we can see 194 rows are there. The left only we have 6 rows that is having NaN values, and right only is 0. So we have to be specific about the duplicate keys that will be available in the data frame that needs to be merged. All right. So what happened is like, so let's say, so this is our new merge. So here what happened is like the first row is again concatenated or merged with the existing regions. So we have a new data frame that is to be merged. So when we merge that, what happens is the north is so north will be, so whenever the very north comes, it will be duplicated. So earlier it was 200, now it will become 240. That is the north rows will be duplicated. So before merging, we have to see for duplicate rows, but not duplicate rows itself. The keys should not have duplicates. So north, south, east, and west are the keys that we are using to merge. So we have to be careful on that. So rest of this is self-explanatory, and you can just practice these questions. So now we move on to matplotlib. So matplotlib is or matplot library is used to do the visualization. Okay, so we quickly do this. So many a times when after we do our data preprocessing or data analysis, everything, when we want to present, it is always nice to create pictures or visualization that can be easily um, perceived by the audience or anybody who is listening to the presentation or anything. So we use this matplotlib library for that. So if we just use the PLT is like how we are going to. So this is the standard way of importing the matplotlib library. So matplotlib.pyplot as PLT. Then we can use plt.plot, and if we give any value, it is going to any series of values, we'll get a plot. Now, if more, so this is the standard. This is the easiest way to do it. But usually, this is what we prefer doing, because in many times in a single figure itself, we can have different plots, like one plot in kind of like a column and rows of plots. We'll see that. So here we are just loading the data. Okay, so this is a simple, let's say a series or a sequence or a list of numbers. And if we just use plt.plot and give this number, it gives this series or give the sequence, sorry, we'll get a plot. So plt.show will show the plot. So here, these indices, so these are the values. And here we have the indexes. So 0, 1, 2, 3, 4. It will go from 0 to 4. Since we are not giving any y value, right? If you give y value also, so if you give x and y values, so sorry, here we are not giving any x values. So let's say if this is x-axis and this is y-axis, all our things, all our values that we give are considered to be y. Now here we have the x-axis, it is line space of 0 to 1 with 100 divisions, and y is x square. So here we will plot plt.plot, we'll give the x and y. If you don't give x, it will just whatever we give. If you give two values, the first value will be x and y. If you give one value, whatever we are giving will be considered as y. So let's say. So here we can give x label, y label, the title, and all those things. So here is the function. Here is the function that is plotted. So we have to always call this plt.show. Now figures and axes. So what's the difference between that? So figure is a whole canvas, like the window, the page, the file that we save. But in axis is one plot area. So it has its own x-axis and y-axis. Then it has its own title and data. So a figure can hold multiple axes. Almost every matplotlib method you want leaves on this axis. So when we move from PLT to X or axis, we have some changes, like the title becomes set title, and X label becomes set X label, and similar cosmetic changes. Okay, so let's see how it differs. So here we are fig and figure and axis equal to plt.subplots. We are giving the figure size is 6, 4. and the dots per inch is 100. So that is just the resolution. Now we are plotting x dot plot, the similar thing what we have done before. But it's a similar plot or same plot, but with explicit objects. So if you see the figure is, where you see, yeah. So this fig is a figure, and x is a axis inside the figure. So why does this format matters, right? So when we can do the same thing with plt dot plot and all those things. So when we want to do something like this, so this is one figure and two axes. So we have left or axis at 1 and axis 2. So here we are giving another command that is 1 comma 2. So that defines one row and two columns. All right. So we have the x1 will give plot xy. Then axis 2 is giving xn, square root of x as the plot. And we can give different titles for our axes. And super title. Super title means a single title for the entire figure. Then we have figure dot type layout. So it's just for when we save the figures to um, stop overlaying or anything, and so it will make our figure look good. Let's see what happens if we do without that. So we can see that there are a lot of gaps here and all those things. So if we use tight layout, all those things will be all taken care of by the matplotlib library, and we'll get a neat figure. Now let's say we have two data sequences, like the temperature at Bangalore and Delhi. Then we have the days, that is the range from 1 to 11. Now we are going to plot a figure with different markers, or we are going to plot two data or two sequences in the same figure. So we have to just plot sequentially, and we'll get the data, or we will get the figure. But if you just plot like that, so let's say if you just plot, and if we don't know if this is blue is Bangalore or black is Bangalore, so that for that we have to give this label. So we have here a label, and we can choose the color or the line style. Everything depends, and also the markers also depends. So here the Bangalore is in black color, and the marker is this one. This symbol denotes the triangle marker. You can use any kind of markers. And also, if we use this ax.legend, we can see the legend also printed along with the figure. Okay, so this alpha is just so alpha is kind of like a parameter that is used to increase or decrease the opacity of the grids. So if we increase this, so let's say 1, then we can see that these lines, these grid axes will be more colored, or it will be dark. So if we decrease that, we can see that they become lighter color. So it is not necessary to give these things like explicitly, like the marker line or the color. We can just give it as a single. So this will do the same thing. So it is for it follows this format, like the marker style or marker, then the color and the line style, right? So let's see. So here we are trying to plot the centuries of different batsmen. Okay, so we are plotting two figures. So figure 1, 2. Okay, in the figure 1, what we are trying to do is we are just trying to plot, or we are just trying to give the values as such. And let's see what it does. And in the figure 2, we are trying to set a limit, right? So if we set a limit, so if it's from 60 to 105, the y-axis is limited from 60 to 105. Okay, so let's see. The readability is more when we do this, right? So if you look at this figure, so we cannot see any remarkable difference between this one and this one. And this one is also like there's kind of not a huge difference. But whenever we uh, use or we limit the y-axis into our range, then we can see that the Sangakkara century is clearly below 65, and I think this is below 70, right? Oh, it's 71. So maybe we should add the grid lines also. Then it will be, let's see, if we add. Yeah. So now it's kind of more readable, right? So we can clearly see that Sangakkara has scored less than 65 centuries, and Kohli and Ponding are above 70, and Sachin is way ahead of me. I don't know if this is the current statistics, but it is what the data we have. Now let's see some of the plot types. So what we have seen is the line bar line, then a value per category, that is the bar diagram. Then we have histogram, then scatter plot, and pie plot. So this is the bar plot. So then what we have just seen right now. So this we have, and also we can use E for each bar. If you want to add text, we can use this AX dot text, and we have to give the X and Y first, and whatever text that we need to give. Then we have the horizontal bar, so it is just the bar H. Okay, then let's move on. So here we have so from the pivot table, we are again creating the pivot table using the revenue and customer type. So here the X position is the length of the pivot table. So here we have the headphone, laptop, phone, and tablet, and we have the customer type in each of that. So here we are plotting the bar plot. So this is the X position, this is the width, and we are giving the values. Then histogram. So here we have 3 different histogram for the same data. So we are plotting a subplot of 1 row and 3 columns. So what we are changing here is we are changing the number of bins we have. Number of bins means, so here the bins is this a single thing. So here we have 1, 2, 3, 4, 5. If we increase the bins, the number or the bit changes, or it is more refined. So let's if we have 5 bins, then if we um, divide these 5 bins into another 4, so what we are going to get is 1, 2, 3, 4. These 4 will be available. Similarly, if we further reduce this 1 into 3, we will end up with the bins equal to 60. So the bins define the refinement in the histogram. Then scatter plot. Scatter plot is nothing but so it's like we can, if you have an X and Y. So let's say we have height and weight of class students in a class, and we can just scatter it, right? So for one height, so for one student there will be height and weight. So that will be kind of like x. If we group it by x and y, so x will be height and y will be weight. So we'll have one point in the 2D frame. So similarly, for all students, we can do that. So here what we have is, so let's see the data first. So here we have the data, right? So what we're plotting, sepal length and sepal width. So here we have the sepal length and sepal width. So we are doing a scatter plot for these two quantities, and we are grouping it by the species. So let's see why we are just grouping it by species, because we want to color them differently. So what we have, we can see that. So this is a plot. So for Sendosa, we have the sepal length and sepal width here for one of the sample, and similarly for other samples. So we can see that a grouping is visible here. So this is all Sendosa, this is all versicolor, and this is Virginica. So that's where scatter plots are useful. So it's so if you just give this data and say the sepal length and sepal width, does it matter or what? We don't know, right? So if we plot it, we can clearly see that Sendosa has a different groupism itself, or the Sendosa's sepal width and sepal length, that feature itself is enough to segregate that from other groups. Whereas if you see the versicolor and Virginica, even though we can see that Virginica have higher sepal length, but it is not very clearly distinguishable. So all these visualization tools are used just to um, communicate in a better way. Rather than using numbers, visually we can communicate in a better way. So here we have the pie plot. So it's just what we can say is pie plots are used just to show the percentage of different categories. Okay. Now, so when we first introduced the subplots, we had used here like x1, comma x2, and kind of things. That is not necessary. So this is the standard way of defining different axes. So here, if we figure axis and 2, 2, so the axis 0, 0 will be the one that comes here. So this 0, 0, this will be 0, 1, this will be 1, 0, this will be 1, 1. Okay. So we can just give this indexing and plot whatever plot we want. So here we have bar plot, histogram, scatter plot, and what is this? It's just line plot. All right. So here we have the different plots. So here it's another way of doing it. So here how we are doing is, so instead of giving a number here from the data, we are calculating how many columns we need depending on the unique species. And also here we are using share X and share Y. So what it does is, so if you look at the previous columns, we all have this X-axis, Y-axis values here and another values here. So, and also X-axis have values and here. So if this data is saying, or if the class, let's say here in this case, the species are different, but the data represents the same. And so what it does is, so all these scale will be shared between all the columns. So that so if you don't use this column, so this figure will have the y limit from 0 to maybe 1, so that it will also look a full scatter plot. Similarly, this one will have something from 1 to 2, and this one will be from 1.5 to 2.5. So it will not make any sense. Like so here, if you share the y-axis because the values are same or the nature of the value is the same, so that the distinguishing between or the different species is easily distinguishable based on the petal width and the petal length also. All right. Now, so now what we have seen is like we are using the matplotlib library explicitly to plot whatever we have seen, but it can also be done using if you have a pandas data frame, we can directly plot different columns or different rows. So here we have the revenue data frame, and we are directly plotting that. And kind is bar plot, and the figure size, everything that we are giving. So we'll get the revenue based on the based on the products. And group plots are also possible. So from pivot, we can directly plot it. So whatever columns and rows that we have used during the pivoting operation, that will be taken care of by the pandas and matplotlib together. Now we have the box plots. So box plot are like kind of it gives. So this is kind of a quartile plot. So here we have outliers. So this represents the outlier. Then this is the minimum value, maximum value. Here we have the mean value and the quartiles. So this will be 75% and 50%. So it is used to see the distribution of data based on the in a column or in a species, all those things. Whatever data we give, this will give the nature of the distribution of the data. Now, once you have created all these things, how can we save it, right? So we have different plots and everything. So what we do is we use the save figure command. So fig.savefig, and we give the name .png. Then we give the resolution, and this is to have a tight layout or no spaces in between. So if you see, we have saved here one figure, so we'll get it. Even we can save the same thing in different format, like let's say PDF. PDF is also possible. So here we got the PDF. It will take some time. So PDF. So sometimes you're required to send it in PDF format. So it depends on what the extension that we use here. So all these are also possible: PNG, PDF, SVG. Okay. Now here you have some practice questions that you can do. So now we'll move to the last notebook for today. So it's this is also a visualization tool. So it can be seen as an advanced version of matplotlib. So what it does that matplotlib does not, it's understand the data frames. Like we can just pass the column names, and it's not arrays like what we have done in the using the matplotlib. And it's also do the statistic like a distribution, regression, all those will be computed. Okay, then the categorical things will be taken care of. So it makes a more meaningful or more complex figures, but easy to treat. So here we have the data that we are loading. Okay, so here we are just just renaming the unknown things and everything. It's just data preprocessing now. So let's how we are importing that. So this is the so it's import. Yeah. So this is how we import Seaborn. So import Seaborn as SNS is the standard way of importing it. So let's see. So we have plotting. We were just using one cross three plots or subfigures. Then we just need to give the his plot. Then data we can directly give the data frame. So if you remember in matplotlib we had to be specific about the x-axis, y-axis, and all those things. So but in here we can just directly give the data, and we can specify the x-axis like the names from there, like the petal length. Then the bins we can specify, and axis is axis 0, so it will be the first axis. Then we have the KDE plot. So KDE plot is nothing but it's a kind of like an kernel density estimate. So it is a smooth curve which shows the distribution, probability distribution. So here, if you see this one and this one, we can see how it is moving. So the combined, so his plot. So again, we are plotting the his plot, and we are giving the KD is equal to true. So we can see both together here. We have the histogram and the KDE plot. Then again, we are plotting the his plot, and here we give the hue. Hue means based on what values it should separate the data set. So here we are separating the data set based on the species. And for each species, we will be plotting the KDE plot as well. So you can see the plot looks very nice and it's very distinguishable as shown here. Then categorical versus number, that is box, violin, and all those plots. So it's all kind of similar, but different, maybe different use cases. All right, so here the box plot gives the minimum, maximum, and mean. Similarly, the violin plot shows a probability distribution, um, like a normal Gaussian distribution or something. And so that is what violin plot comes. Then it's just the distribution of the data. That is a strip plot. Then we have the bar plot also. So in this bar plot, we have the standard distribution also given. So this is the combination of box plot plus the raw data. Then we have the scatter plot that is similar to what we have seen before, just visually more pleasing when compared to matplotlib. But one good thing is we can use the regression plot also. So regression plot is where we can see if the um, regression, where the data follows the regression line or not. Then we have the joint plot. So in the joint plot, we can specify what are the x, y axis and hue, and it will also plot the probability distribution along the axes. So if you want the KDE distribution, we can define that also. So here we have the KDE. Then we can use the hex plot. And any kind of plot can be defined to come as the plot. Then one more thing is like So if you don't know, or if you are just starting with the data, so we can every numerical column we can compare and see the distribution. So it's like so we just use the pair plot and give the data set, and based on what species, what category we need to uh, categorize them. So that is given in the hue. So you can see that. So here we have this sepal length, sepal width, petal length, petal width. Same thing is shown here also. Sepal length, sepal width, and whatever other two category numerical data types. So you can see that each of them is plotted against each other. So here we have the pair plot. So what all pair plot that we need? So here we have the distribution. If it is between the same data type, so it's a sepal length and sepal length, right? So there is no point in plotting the scatter plot in sepal length and sepal length. It will be just along this line that we'll get the values, because whatever comes here, it will comes there also. So we'll plot the distribution here, and these are the scatter plots that we have seen already. So it actually gives a, so based on what values there is distribution, all those can be inferred from these plots. So if you look at this, if you see the petal length and petal width panels, so petal length and petal width, so there is a clear distribution, right? So here is one species, that is Sendosa, then versicolor and virginica. So maybe we can use these two values to do our final analysis. This is a correlation plot. So correlation plot is also the same thing. So it's kind of what values are correlated to each other. Negative means the negative correlation means it's going in the opposite direction. That is, if one is increasing, one is decreasing. And if it's the same values, it is a perfect correlation, right? It's one. So as we have already seen, petal width and petal length have the highest correlation. All right, all right. So this is a facet grid. So it's like a one panel per category, and the axes are the same. So the matplotlib we had used the same x share x and share y is equal to true. The same thing will be done by the Seaborn library in this command or in this syntax. All right. So we have already seen this. It's same as violin plot. Okay. So Seaborn is a library that is on top of matplotlib, we can say. So what all matplotlib does, all those cosmetic things that we do, like the labeling, title, legend, everything can be followed from the matplotlib library. So we'll quickly do a quiz. So we have just 10 questions, and all right. So if a DF has 100 rows, what does DF call returns, and what does DF double bracket call returns? If anybody is online, they can unmute and speak. All right, we know that DF call returns a series, and the other thing returns a data frame. The answer is. Then question 2 is like the index is 0 to 99. Then how many rows does df.log return and df.ilog return? So we know that df.log will include the 5 and df.ilog will not include the 5. So it should be 6 and 5. 6 and 5. Then which of these correctly filters for laptops with low revenue over 5%? And select. So there can be multiple answers. So we know that this index is not correct. So this can be correct.
And B and D.
Yeah, B and D. Then we have the next question, sales revenue. A flag is equal to big. What happens on Pandas 3.0? So whatever we have just studied.
Raises key error, maybe.
Why?
Because temporary subset using indexing raises a key error, right?
Will not raise a key error. So it will give an error.
I'm
It
not
will give a
sure.
warning. It will give a warning like because so let's say what it is doing. So let's say what is the warning. So warning is it's a kind of like a copying warning. Okay. So here is the explanation. So it's a mask thing. Then sales has 200 rows and 6 of them with a missing region. Then region has 4 rows, 1 per region. How many rows in the sales dot merge and inner return? So inner will not remove the NaN values or the missing regions. So we'll get the inner will remove the NaN values. So we will get 194. So sales dot group by product. So what will be the product? Product will be an index because we are not saying as index. We are not setting as a it does false. So it will be an index. Then we have you want each row to carry its product's average revenue alongside its own. What do we use? So we have already seen that we have to use the transform. Right? So we have to use the transform. Then from matplotlib, so matplotlib.title A inside a figure with 2 subplots. Which panel gets the title? So there will be nothing right because whichever is current one will get the title because a PLT always sees which axis is currently active. Okay, then an old tutorial had so that is not needed. Then you have 150 iris measurements and want to see how the 4 columns relate to each other and split by species, which single call is the best starting point. You have seen that, right? Like, yes, Seaborn is the efficient way to do that. Okay, then, so these are just the solutions. So these are the solutions for the practice set that is given in the other notebooks. All right, so all the notebooks has been uploaded in the drive. So we will again just post the drive link here. So this is the drive link. You can take a screenshot or photo. All right. So from this drive, you can access all the files, including the data. All right. So thank you. Thank you for joining. I'll end the class now.
Sir, actually, is there any book to understand the rationale between all the syntax? To remember everything syntax in Python? The logic, what is the logic, so that you remember so many syntax, no, sir?
It's there is I don't know any textbooks as such. It's better to practice. That's the best way. Like even if we read, we won't remember anything. That's what my experience is. It's better to practice things like write the code and then only then you will be able to remember things.
So there is no any rational book. What is the idea behind it? So you can understand some common syntax like this.
Like there will be some introduction to Python, all those
Oh.
things. So it's better to go and watch some YouTube videos also. So
Thank
there
you,
is some.
Sir.
Yeah.
Sir,
Yeah.
how to that when remember recognize the variables, loops, and condition of but that when I'm just asking you how to remember the codes like which variable I can use and which loop in I should go through and which condition I will work.
Like if
Just
you
very basic.
practice coding only, you will be able to remember those things. So, like if you read things, so if you we just say this one for loop is good, and for something while loop is better, but that does not work like that. Like we will not be able to get good practice or good. We won't be able to remember those things. So always we have to do the coding on hand. But now agents are doing everything, so I don't know if remembering those things also matters or not. So all the ChatGPT and everything is very good right nowadays. So we just need to learn to tell them what we actually need. So that may be the more refined way.
So you have one more this.
Yeah, one more class will be there.
Yes, sir. Okay, sir.
Yeah.
Next
Yeah,
week,
thank
no,
you.
sir. Thank
Yeah,
you, sir.
next
Good
week.
night.
Okay, thank you.
Thank you.